In this slide, we will see how the Ether channel works by analyzing this network diagram. First, we will start with the requirement to configure the Ether channel. Then we will see how the traffic will be going back and forth between the two switches after it's being configured with Ether channel. And lastly, we will see what factor influence the traffic in an Ether channel. So as you can see, these two switches are connected to each other by 3 Ethernet links, and we can bundle the links together to form an Ether channel. And by theory, we can configure up to 8 identical active ports. So what do we mean by saying identical ports? In Ether channel, the ports are identical if they share the same speed, duplex mode, chunk mode, native VLAN, allow VLANs, and port types. So as long as the ports share the same characteristic like this, they can be grouped to form an Ether channel, and we can configure up to 8 identical ports. So now we have Ether channel configured between the two switches. Let's see how the traffic gonna be going back and forth across the Ether channel links. Let's see. First of all, let's say if this computer has a package and forwarded to this switch like this, this switch will have to extract the information from the package, such as the MAC address, the IP address, the port number, and based on the load balancing methods configured on this switch, along with the number of links in an Ether channel, it will select a link. For example, in this case, it will select this link to forward the package out to this switch and forward to this computer like this. Now this computer will respond with a package back to this switch. This switch will also have to extract the same information, such as the MAC address, the IP address, the port numbers, and based on the load balancing method configured on this switch, it will make the decision to select one of the links on an Ether channel to forward the package, and in this case it will, for example, forward the package on this link and to this computer. So as you can see, the load balancing methods need to be configured on the two switches, and though load balancing methods can be the same or can be different, we will talk more about the load balancing method type in the next slide. But what do we have in the load balancing method, or in another word, what the load balancing method actually is? The load balancing method actually is contain the hash algorithm. The hash algorithm will be used to select a link based on the number of links, the MAC address, the IP address, or the port numbers of the package to select a link in an EtherChannel to forward the package. There's some important notes here. First is after a link is selected, only that link on that switch will be used to transfer the frame between the two devices. So as you can see, the load balancing methods on this switch is fixed. The load balancing on this switch is fixed. The IP address of this computer, the MAC address of this computer is fixed, and the port number for the application on this computer is also fixed. Same thing for here. The IP address, the MAC address, and the port number for the application are fixed, so there's nothing changed. So when it pick up this link, it will be used, this link will be used to forward the package forever. But if they use a different application or different computer right here, maybe this link will be selected, or forward to a different computer over here, or maybe this link will be selected. So if for the same computer, the same application, the only one link will be selected to forward the package between the two computers. That's what this really means, because all the parameters are fixed or no change. In an EtherChannel, there's a built-in mechanism to protect the links from the loop, and it's stated by the two rules. The first rule is no inbound broadcast and multicast frame are sent back out over any of the remaining ports. What does this mean? For example, if the switch forward the broadcast or multicast frame to this switch across this link, and the package will be going into the switch, and because it's the broadcast message or broadcast frame, so it can be flooded on this switch out to all the ports in this switch, to this port and to this computer. But because these three ports are configured as an EtherChannel, there is no traffic forwarding out to these two ports. So it going in here, it will never forward back in here because it will causing the loop. So how about the outbound broadcast or multicast frame? They are load balanced like any other traffic. So this switch are being flooded by the broadcast or multicast frame, and it will based on the hash algorithm and IP or MAC address or port number, and it will make the decision to forward to this link based on the load balancing method configure. So the outbound broadcast and multicast frame are load balanced like any other frame. And we will talk about how the hash algorithm work in detail in the next slide. So we finish on the how the EtherChannel works. In the next slide we will talk more about the type of the load balancing methods. In this slide we will talk about the types of EtherChannel load balancing methods. So before we begin, I would ask a question. Why do we need so many load balancing methods? The answer is we need to have different load balancing methods to satisfy with the different traffic patterns. In this case we have, based on the IP address, so you can only pick this method if you know for sure that in your network is IP network. And the MAC address, in many cases you should not choose a MAC address, or it's not gonna distribute equally across the multiple links. And the port number. So let's look into the IP address first, and we can figure out is for the MAC address and the port number. So for the source IP address and destination IP address, the hash algorithm will look into the source IP address and extract the last bits based on how many bits, based on the number of links. So one link is only need 1 bit, 2 link is also need 1 bit, 3 and 4 links is need 2 bits, because 2 powered by 2 is 4. And we know that we can configure up to 8 links, so the most is can extract is 3 bits, because 2 power 3 equal 8. So it will, in this case for the source IP address, it will look at the last up to 3 bits to extract, so if it is 0, it's gonna select the link number 1, but if it's 7, it's gonna select the link number 7 to forward the traffic. Same thing for the destination IP address. But what about the source and destination IP address? So the hash algorithm have to look at both the source and the destination IP address, and based on the number of links, it's gonna do the source to find out which link it need to forward the traffic to. And same thing is applied for the source MAC address, destination MAC address, source and destination MAC address, and source port number, destination port number, source and destination port number. So, and you can see, if only one parameter is used, hash operation is bits, but 2 parameters, source and destination, is will use a source hash operation. And another thing that you need to notice is for the source IP, for the IP address and MAC address, all switch model will offer, but for the port numbers only the 4500 or 6500 can offer. So if you configure it on the different model other than 45 or 6500, you will not see the option for the port numbers. In this slide we will see how the hash algorithm works. First of all, we need to know the IP address, the MAC address or the port number, and it has to be converted into the binary string. And in this case I just pick up a random binary string like this. And we also need to know the number of links in EtherChannel. This is to decide how many bits will be used in the hash operation. So 2 links or less will require 1 bit. 4 links or less will require 2 bits. 8 links or less will require 3 bits. And in this case I just pick up 3 bits. So it means in the EtherChannel we must have 5 links or up to 8 links. And based on the load balancing method that we configure on the switch, it will perform the bits operation. The bit operation is performed if only one address or port number is hash. The switch will forward X frame using by one or more low order bits of the hash value as an index into the bundle links. So in this case, the switch will forward to the links number 5, because 2 power 2 equal 4 and 2 power 0 equal 1. So 1 plus 4 equal 5. So links number 5 will be used to forward the frame. Or we can use the sort operation. The sort operation is used if 2 addresses or port numbers are hash. The switch performs an exclusive OR or sort operation on one or more lower order bits of the addresses or TCP UDP port numbers as an index into the bundle links. So in this case we pick the same random string and it will perform the sort operation. 0 0 0. So link 0 will be used. So I will also include the sort operation in here so that we can figure out. So the sort operation is really easy to remember or to memorize. If the input are the same, it will become 0. If the inputs are different, it will become 1. So after that, the links to be used will be selected. So for the bit operation, the links number 5 will be used. For the sort operation, the links number 0 will be used. And those links are assigned in a round robin fashion. I will talk more about that in the next slides. In this slide we will talk about the link index assigned by hash algorithm. And you can see in this table, this is the link index from 0 to 7. And if we have only one active link in the ether channel, so it's required 1 bit, and after the bit or the SAW operation, the value can be either 0 or 1. But because there's only one link, so the link 0 will be used. Now if we have two active links, so it's also required 1 bit. But if after the SAW or the bit operation, if the value is 0, the link 0 will be used. And if it's the value is 1, the link 1 will be used. If we have 3 active links, so it's required 2 bits. And if the result of the bit or SAW operation is 0, 0, link 0 will be used. 0, 1, the link number 1 will be used. 1, 0, link number 2 will be used. But 1, 1, the link number 0 will be used. That's how it's a round robin. Will feel like this. Now if we have 4 links, so after the SAW or the bit operation, if the result is 0, 0, link 0 will be used. 0, 1, link 1 will be used. 1, 0, the link number 2 will be used. 1, 1, link number 3 will be used. Now if we have 5 active links, and after the bit or the SAW operation, if the result is 0, 0, 0, the link number 0 will be used. 0, 0, 1, the link number 1 will be used. If it's 0, 1, 0, 0, link number 2 will be used. 0, 1, 1, link number 3 will be used. 1, 0, 0, link number 4 will be used. But if it's 1, 0, 1, link number 0 will be used. 1, 1, 0, link number 1 will be used. 1, 1, 1, link number 2 will be used. If it have 6 active links, so it's also require 3 bits. And if the value is 0, 0, link 0 will be used. 0, 0, 1, link number 1 will be used. 0, 1, 0, link number 2 will be used. 0, 1, 1, link number 3 will be used. 1, 1, 1, 0, 0, link number 4 will be used. 1, 0, 1, link number 5 will be used. And 1, 1, 0, link number 0 will be used. 1, 1, 1, link number 1 will be used. And you can figure out for the cases where it has 7 or 8 active links. So as you can see over here, it is better if you have the active links at the power of 2, like 2, 4, and 8. The frame will be distributed evenly. So let's move on to the next slide. In this slide, we will go into the example of how hash algorithm works. In this case, we will analyze the packets sent from the IP address 172.22.70.122 to the IP address 172.22.70.127. So this is a source IP address and this is a destination IP address. So let's go into the first case. We use a source IP address as a load balancing method. So it means this will be used to analyze, and in this case we need to convert 122 into the binary, and we have this binary string, and the number of links in EtherChannel is 2, so it means 1 bit will be used, and we use a bit operation. So we have this, and we know that the link number 0 will be used. Now move on to the second cases where we use a destination IP address as a load balancing method. So this IP address will be used to analyze, and we have to convert 127 into the binary string, and we have these strings. In this case the number of links in EtherChannel is 3, so we have 2 bits, and we use a bit operation, and here's the result. So 1 it means 3. We convert it into link index 3, but in this case we have 3 links in our EtherChannel index from 0 to 2, so it means the link number 0 will be used. You can go back to the previous table in the previous slide to compare it. Now we're gonna take a look at the third case where we use the source and destination IP address as a load balancing method. So it means we have to use a source IP address and destination IP address to analyze. First, let's take a look at the source IP address, and we need to convert 122 into the binary, and the destination IP address, and we're gonna convert 127 into the binary string. And now we know that in the EtherChannel we have 4 links, so it's required 2 bits for this and for this, and the source operation of 1 and 1 is 0, and 0 1 is make it 1, so the link will be used is link number 1. Now let's analyze the fourth cases where we also still have the source and destination IP address as a load balancing methods, and we're gonna repeat the same step, convert 122 into binary and convert 127 into binary. But in this case we have 7 links in our EtherChannels, so it's required 3 bits for the source IP address and 3 bits for the destination, and we're gonna perform the source operation, and we have a result of 101, so it means the link number 5 will be used. In this slide we will talk about how to choose the right load balancing methods. As you know, we want to choose a load balancing method so that the traffic will be distributed across all the links as equal as possible. In order to do that, you need to understand the traffic patterns. So what do I mean by saying the traffic patterns? So let's analyze the following cases and we can better understand on the traffic patterns. The first case is when a single server receiving most of the traffic on an ether channel. So and you could imagine that like there's a lot of computer trying to access or upload files to a server, and of course in that case the destination IP address is always remain constant in many conversations because it's the same destination IP address of that server. And if we use a load balancing method using the destination IP address, so only one link will be used and the remaining links will be left unused. So one link will be overused and all the other links being idle. So in that situation we should choose the source IP address. So each computer will be distributed across each links instead of the destination IP address, or even the source MAC address will work as well. Now the second case is if in our network there's a heavily traffic sent back and forth between the two servers installed with many applications. So in this case, as you can imagine, the IP address and the MAC address remain the same for both servers. So we also know that it's installed with many applications, so would give us a clue that each application usually use a different port number. So if in that case we should use a port number as a load balancing method. Now in the third case is when two routers forwarding frame to each other. Both source and destination MAC addresses remain constant because it is the MAC address of the routers. So it means that one ether channel links is used if we use the MAC address. In that case, even source or destination MAC address is still remain constant, and in that case we should choose the IP address instead if it applicable, because in some network it doesn't use the IP addresses. In the fourth cases is in some application EtherChannel traffic might consist of protocols such as IPX or SNA. Frames might be switched along with IP. So non-IP protocols need to be distributed according to the MAC addresses because the IP addresses are not applicable. So in that case, we should choose the MAC address instead. Configuring EtherChannel load balance. We should use the following command to configure the frame distribution for all EtherChannel switch links. So it means that there's no way we can configure individual load balancing methods for a set of links or a subset of links. It is configured at a global switch configuration level, and you can see over here is at the configuration mode, and the command is port dash channel load dash balance methods, and we should put in the method in here: source address, source IP address, destination IP address, source and destination IP address, and same thing for the MAC address or port number. To verify the load balancing methods currently in use, we need to use the command show EtherChannel load balance load dash balance. So it's as normal, the show is run at the privilege mode. Show EtherChannel load dash balance. To verify how effectively a configure load balancing method is performing, you can use the command show EtherChannel port channels.